Hello students, welcome back to my channel. In last class we discussed hybridization of sulfate ion, carbonate ion, boron hydride. One is xenon trioxide. In this, what is the central atom? Xenon. So here xenon belongs to which group? 8th group. So what are the 8th group elements? Helium, neon, argon, krypton, xenon, radon. Okay, here actually noble gases means 8th group elements are chemically inactive, chemically inert. So but here whenever more electronegative atoms like fluorine and oxygens, whenever more electronegative atoms like fluorine and oxygens will come very close to the krypton and xenon, then what will happen? These atoms will able to lose electrons. Then they will convert into positively charged ions. So that's why these elements also called noble elements, noble gases. Actually, at ordinary conditions, at room temperature, they all are chemically inert. But here, whenever more electronegative atoms like fluorine and oxygens will come close to the krypton and xenon, then these atoms will able to lose electrons. Understand? Okay. So now we will see what is the hybridization of xenon trioxide. Okay, central atom is xenon. So it is placed in the 8th group, means 0 group element. So here group number is what? 8. So here next V is the number of monovalent atoms. Oxygen is divalent. So we don't consider. So V is equal to 0. Then is this anion or cation? No. It is a completely neutral molecule. So then A is equal to 0 and C also 0. Okay. So then number of electron pairs EP is equals to group number plus number of monovalent atoms plus magnitude of anion minus magnitude of cation is divided by 2. It is the formula already we discussed in last 2 classes. Okay. So then EP is equals to G means 8, V means 0, A means 0 and C also 0 is divided by 2. So then here 8 by 2. So that is 4. 4 means its hybridization is sp3. Okay. So then here in this how many bond pairs are there? Bonded atoms are 3 bonded atoms. 3 oxygens means 3 bonded atoms. Then to find out number of lone pairs, LP is equals to electron pairs minus bond pairs. So that is electron pairs of 4, bond pairs of 3. So that is 1 lone pair. Okay. So for sp3 hybridization, if 3 bond pairs and 1 lone pair, shape is a trigonal pyramidal shape or pyramidal shape. Trigonal pyramidal. Okay. So here the shape is like this. Xenon. Okay. Actually here how many lone pairs are there? 1 lone pair. Actually for sp3 hybridization, what is the shape? Tetrahedral shape like this. This is the tetrahedral shape. But here how many bonded atoms are there? Only 3 bonded atoms, 3 oxygens. So what about this one? That is a lone pair. This is lone pair. So we know that the valency of oxygen is 2. So that's why here double bond will be formed. Between xenon and oxygen, double bond is present. So what is the shape of this one? This is a pyramidal shape or trigonal pyramidal. Trigonal pyramidal. Its bond angle is approximately 107 degrees. Okay. Next come to the 8th one. What is 8th one? Xenon difluoride. So G is equals to, here in this also xenon is central atom. So here xenon, that is G means xenon is placed in the 8th, means G equal to 8. Next V. Fluorine is the monovalent atom. Okay, so that is how many fluorines are there? 2. So it is neither anion nor cation. So A equal to 0, C also 0. Then electron pairs EP is equals to G plus 8 plus V 2, okay, plus A 0 minus C 0 is divided by 2. So that is a 10 by 2. 10 by 2 means 5. 5 means sp3d hybridization. sp3d hybridization. Okay, so here in this, how many bond pairs are there? How many bonded atoms? 2 bonded atoms, 2 fluorines are there. Then to find out lone pairs, LP is equals to EP minus BP. So how many electron pairs? Totally 5. 5 minus how many bond pairs? 2. 5 minus 2, 3. So 3 are lone pairs. Okay, here totally 5 bond pairs. If all are 5 totally 5 electron pairs. In that, if all our bond pairs are there, shape is a trigonal bipyramidal. Trigonal bipyramidal, like this. Its shape is like this. Trigonal bipyramidal. But here, how many bond pairs are there? Only 2 bond pairs. But what about remaining 3? 3 are the lone pairs. So here, fluorine, fluorine. So remaining are lone pairs. Remaining are lone pairs. Okay, so in center, what is the central atom? Xenon. So here shape is what? Linear. Linear shape. Linear shape means the bond angle is 180 degrees. 180 degrees. Okay, so next ninth one. So ninth one I want to give a home task. Means if you find out the hybridization and these all factors what we discussed in this. Okay, try to find out. If you know the answer, please mention in the comment section. Okay, so I will reply. No problem. Okay, next we will discuss 10th one. Discuss the 10th kind. Okay, so that is xenon dioxygen difluoride. Understand? So in this also central atom is xenon. Okay, so here G is equal to 8. So number of monovalents how many? 2. Fluorines we have to consider, that is monovalent. But oxygen divalent we don't consider. So we equal to 0. Is this anion? No. Is this cation? No. It's equal to 0. Okay, so then EP is equal to electron pair is equal to G plus 8 plus V 2 plus anion minus cation magnitude by 2. So that is 10 by 2. 10 by 2 means 5. Means sp3d hybridization. sp3d hybridization. So then how many bond pairs are here? Bond pairs how many? How many bond atoms are there? Here 2 oxygens, here 2 fluorines. So totally 4 atoms, 4 bond atoms. Next lone pairs how many? So electron pairs, total electron pairs minus number of bond pairs. So 5 minus 4. So that is 1 lone pair. So 4 plus 1, 5 electron pairs. Okay, if here total electron pairs are 5. So in that all our bond pairs shape is actually trigonal bipyramidal. But here how many lone pairs are there? 1 lone pair is there. So then shape will be changed. Shape will be changed. So that is here actually this one. Actually this one. So then central atom water xenon. Okay. So then here oxygen and fluorine is there. Fluorine one is not there. Okay, understand? So what is shape of this one? What is shape of this one? Tell me. So this is our seesaw shape. Just wait. What is shape of this one? Seesaw shape. But here we have to change it. This lone pair will be shifted to this side. So here we can draw like this. So here in which direction the repulsions are minimum? In that direction these bond pairs and lone pairs will be settled. Okay. So here we have to take fluorine and here lone pair. So what is shape of this one? Seesaw. Seesaw shape. Okay. So this is about hybridization of xenon trioxide, xenon difluoride and xenon dioxygen difluoride. Okay, so here up to this molecule we discussed. These all molecules and ions we discussed in these classes. Okay, so in next class we will discuss IF7, I3 minus. I3 minus is very important, very important. Okay, and if it is possible, I will explain remaining also in next video. I hope you understood my class. Okay, please like and subscribe and share it this video to your friends. Thank you very much.